The interesting thing about transformations is that you can find the inverse of a given matrix using these transformations. So let us look at the process by which we can find the inverse of a matrix using these transformations. So let us take an example. A is equal to 1 2 1 3 1 2 1 4 2. So let us say that you want to find the inverse of this matrix. So we already know the simple method to find inverse using the cofactors matrix. Adjoint of A by det A is the inverse. Now let us discuss another method by which you can find the inverse of this matrix, that is using transformations. Elementary or a series of elementary transformations called compound transformations. Now, so the process is something like this. So the first step is we write A is equal to A times I. We write A is equal to A times I, right? So A is equal to A times I. So what I write is 1 2 1 3 1 2 1 4 2 is equal to so A is equal to A times I or I times A also, because I is the multiplicative identity in matrices. If you pre-multiply a matrix with I or post-multiply a matrix with I, you get the same matrix. So A is equal to 1 0 0 0 1 0 0 0 1 times A. So you start with this step. Now, using elementary transformations or compound transformations, you convert this matrix into identity matrix and use the same transformations in the identity matrix. So as this matrix slowly becomes the identity matrix, using the same transformations, this matrix slowly becomes A inverse. So if you slowly convert this into I and use the same transformations in this matrix, as this matrix gets converted into identity matrix, this matrix gets converted into A inverse. So this is the logic of finding A inverse using elementary transformations. So how to convert this into identity matrix? So if you use the standard algorithm, any inverse can be found out in 4 steps. So let us try to find what those 4 steps are. So to find the inverse of a given matrix using elementary transformations, we have a fixed algorithm called pivot element method. So you use this method. After 4 steps, you always get the answer. If you don't use this method, you get confused. So it's not very easy to convert this matrix into an identity matrix if you arbitrarily do the transformations. So let us use pivot element method. So let us try to understand this. First, the diagonal positions. So these 3 positions are called in a matrix with respect to transformations. So these 3 positions are called pivot positions. Pivot means important in English. Pivot means important. So these 3 positions are called pivot elements or pivot positions, and using numbers in these 3 positions, we'll find the inverses. So in the first step, use 1 to make these 2 elements as zeros. So use the pivot element, the first pivot element, to make the first column into zeros. So what transformations I use is row 2 becomes row 2 minus 3 times row 1. This is 3. I'll multiply row 1 with 3 and I subtract from this. And row 3 becomes row 3 minus row 1. So I'm using the first row to transform the other two rows. We have seen that this compound transformation can be done in a single step. Now what happens if you do this transformation in this matrix? So row 1 is not changing because row 1 is not being transformed. So what happens to row 2? Row 2 becomes row 2 minus 3 times this. So 3 minus 3 is 0. 1 minus 6 is minus 5. 2 minus 3 is minus 1. 1 minus 1 is 0. R3 minus R1 is 2. R3 minus R1 is 1 is equal to. So whatever transformation you do in this matrix, you do the same transformation for identity matrix. So here also the first row does not change. So what happens to row 2? Row 2 minus 3 R1. 0 minus 3. 1 minus 0. 0 minus 0 is 0. 0 minus 1. You get minus 1. 0 minus 0 is 0. 1 minus 0 is 1. So you have to observe something interesting here. As you make these two as zeros on the LHS, these two zeros gets disturbed, the other zeros remain intact. So in the first step, remember that these two elements will become 0 in the A matrix and these two zeros will get disturbed in the identity matrix. The second step. So in the second step, we use this as my pivot element. Using this, I'll try to make these two as zeros. So what do I do? R1 becomes 5 times R1 plus 2 times R2. The method is something related to the LCM. The LCM of 5 and 2 is 10. So I'll multiply the first element with 5 and the second element with 2. And row 3 becomes 5 times row 3 again plus 2 times row 2. 5 times row 3 is 10. 2 times row 2 is minus 10. So they get cancelled and you get 0 at these two positions. Now, so what happens if I use these transformations? Now R1 and R3 are getting transformed. So R2 remains intact. So R2 does not change. So what becomes of R1? R1 becomes 5 times R1 minus 2 times R2. 5 times R1 plus 2 times R2, this becomes 0. 5 times R1, 5 minus 2 is 3. And R3, 5 times R3 plus 2R2, again 0. 5 times R3 is 10 minus 10, this becomes 0. 5 minus 2 is 3. So this is equal to. So here also you use the same transformation. So R2 remains intact, minus 3, 1, 0. So what becomes of R1? R1 becomes 5 times R1 plus 2 times R2. So 5 minus 6 is minus 1. 0 plus 2 is 2. 0 plus 0 is 0. 5R3 plus 2R2. So minus 5 minus 6 minus 11. 0 plus 0 plus 2 is 2. 5 plus 0 is 5 times A. So in the second step, these two are already zeros. The zeros that you already have will not get disturbed. So these two have become zeros and these two zeros have got disturbed. So as you can see, when these two have become zeros, these two zeros have got disturbed. When these two have become zeros, these two zeros have got disturbed. Now these two zeros are intact and these two have not become zero. Now let us use the third pivot element to make these two terms as zeros. That's the third step. So using 3, how do you make these two as zeros? So R1 becomes R1 minus R3 directly. 3 minus 3 becomes 0. R2 becomes 3R2 minus 3 plus R3. So now what happens if I do this? The last row will remain intact, 0, 0, 3. Now what happens to the R1? R1 becomes R1 minus R3. So 5, R1 minus R3 is 0, 3 minus 3 is 0. R2 becomes 3R2 plus R3. So 3R2 is 0 plus 0 is 0. 3R2 minus 15 plus 0. So this becomes minus 15 and R2 becomes 3R2 minus 3 plus 3 is 0. So, and you get the same transformation here. R3 is intact, minus 11 to 5. What becomes of R1? R1 minus R3. Minus 1 plus minus 1 plus 11 is 10. R1 minus R3. R1 minus R3 is 0. R1 minus R3 0 minus 5 is minus 5. And 3R2 plus R3. 3R2 is minus 9 minus 11 minus 20. 3R2 3 plus 2 is 5. 0. 3R2 is 0 plus R3 is 5 times B. Now you have 0, 0, 0, 0, 0 and here things have got disturbed. Now the final step, you have to make this into an identity matrix. So what you do is R1 becomes R1 by 5, R2 becomes R2 by minus 15, R3 becomes R3 by 3. R3 becomes R3 by 3. So if I do these transformations, this becomes 1, 0, 0, 0, 1, 0, 0, 0, 1. And what does this side become? R1 by 5. If I divide R1 by 5, I get 2, 0, minus 1. R2 by minus 15. So minus 20 by minus 15 is 4 by 3. 5 by minus 15 is minus 1 by 3. 5 by minus 15 is minus 1 by 3. Next, R3 by 3, minus 11 by 3, 2 by 3 and 5 by 3 times A. So this side has become identity matrix, hence this is nothing but inverse of A. So this is how you find the inverse using the elementary transformations. So if you want, you can get a 1 by 3 outside. So this is equal to 1 by 3 times. So this becomes 6, 0, minus 3, 4 minus 1 minus 1, minus 11, 2, 5. This will be my A inverse. So this is an essay question for you. So you need to understand how to find inverse using elementary transformations. So in the questions you might be asked to find A inverse specifically using elementary transformations. So use this 4 steps or the pivot element method. You get the answer in the 4th step. So if you haphazardly do the transformations, so sometimes you get zeros, in the next step these zeros will get disturbed and you won't be able to get identity matrix. So be careful and use the method as it is. And you can check whether this is right using your adjoint method. So let us do the same. So now let us try to find the inverse using the adjoint method. See whether you get the same answer or not. So first let us find det A. Det A is 1 times 2 minus 8 is minus 6. Minus 2 times 6 minus 2 is 4 plus 1 times 12 minus 1 is 11. That is equal to minus 6 minus 8 plus 11, which is equal to minus 3. And what is the minus matrix? Minus matrix is 2 minus 8 is minus 6. 2 minus 8 is minus 6. 6 minus 2 is 4. 12 minus 1 is 11. 4 minus 4 is 0. 2 minus 1 is 1. 4 minus 2 is 2. 4 minus 1 is 3. 2 minus 3 is minus 1. 1 minus 6 is minus 5. So correspond to this, what is the cofactors matrix? So these elements do not change their sign. So minus 6, 1, minus 5, 11 and 3 are intact. And the remaining numbers change their signs. So minus 4, 0, 1, minus 2. And you need the adjoint matrix. Adjoint of A is nothing but the cofactors matrix transpose, which is minus 6 minus 4, 11, 0, 1, minus 2, 3, 1, minus 5. And A inverse is adjoint of A by det A. Det A is minus 3. So minus 1 by 3 times minus 6, 0, 3, minus 4, 1, 1, 11, minus 2, minus 5. So did you get the same matrix? I'll just send this minus 1 inside. So 1 by 3 times 6, 0, minus 3, 4, minus 1, minus 1, minus 11, 2, 5. So is this exactly same as this? Yes. So you can see that you got the exact same inverse matrix by both these methods. So in the exams, if you are explicitly asked to find inverse using elementary transformations, have to do the previous method. If you just asked to find A inverse, this is a better method, easy method. Thank you.